After that we seen capacitor. Capacitors are passive electronic components having ability to store electrical energy. Capacitor having two conducting plates separated by insulating medium called as dielectric. Here the figure shows the capacitor. These are the two metal plates or conducting plates, and this is the dielectric medium which separate these two conducting plates. Here is the symbol of the capacitor. It is a normal capacitor. It is electrolytic capacitor having positive and negative terminal. Then it is a variable capacitor, and this is trimmer capacitor symbol. Then the dielectric is could be air, mica, paper, plastic, etc. The property of the capacitor to store the electricity is called as its capacitance, and it is given by the equation C is equal to Q by V. And unit of the capacitor is farad. Also there are small units like microfarad, nanofarad, picofarad are used. Then classification of capacitor. The capacitor mainly classified into two groups, fixed capacitor and variable capacitor. The fixed capacitor further classified into two groups, electrolytic capacitor and electrostatic capacitor. And variable capacitors are into three types: ceramic capacitor, air capacitor and plastic capacitor. The example of electrolytic capacitors are tantalum capacitor, aluminum capacitor. An example of these electrostatic capacitors are ceramic capacitor, mica capacitor, plastic capacitor, paper capacitor and glass capacitor. Firstly we see in electrolytic capacitor. Here it is the symbol of electrolytic capacitor. Electrolytic capacitors are polarized capacitor. That means the electrolytic capacitor having the fixed polarity like positive and negative. Here the positive terminal is long lead and negative terminal having a short lead. These capacitors are constructed by using two metal plates, and these are separated by thin metal oxide. Metal oxides acts as a dielectric medium. Value of the electrolytic capacitor ranging from 1 microfarad to 10,000 microfarad. Then aluminum electrolytic capacitor. This is the aluminum electrolytic capacitor, and these capacitors have high working voltage and cost as compared to other capacitors of same capacity. Then tantalum electrolytic capacitor. These are the tantalum electrolytic capacitor. In this capacitor, tantalum oxide is used to separate the anode and cathode. These capacitors are superior than aluminum capacitor. These are the long life, high temperature range. Then electrostatic capacitor. This capacitor does not have any polarity. That is, they can be connected in the circuit either direction in a circuit. It includes paper, mica, glass, ceramic capacitor. Firstly we seen paper capacitor. It looks like that. Here is the paper capacitor. Paper capacitor use paper or thin plastic film as dielectric medium. They are available from 0.0 microfarad to 200 microfarad with working voltage up to 2000 volt. Two most commonly used plastic film are Teflon and Mylar. Applications are used as RF bypass capacitor or coupling capacitor, also used as decoupling capacitors. Then mica capacitor. These are the mica capacitor having plates of the mica. Here is a dielectric medium. Mica capacitor is sandwich of several thin metal plates separated by thin sheets of mica is shown in the figure. These are the sheets as a dielectric medium. Here is alternate plates are connected together and leads are attached for outside connection. The total assembly is covered in a plastic case. Capacitors having values from 50 picofarad to 500 picofarad with working voltage up to 500 volt. And applications of mica capacitors are, these are used in radio and TV circuits, and these are used also blocking and blocking and coupling capacitor. Then ceramic capacitor. The figure shows the ceramic capacitor having the color bands. Here is a 6 is first digit, then second digit, this is a multiplier, and this is a shows tolerance. Ceramic capacitor uses titanium dioxide and barium titanate as a dielectric medium. The conducting plates are made from silver and leads are attached to it, as here shown the leads. This whole unit is kept in moisture proof coating. Small size ceramic disc type capacitor having capacitance up to 0.01 microfarad. Ceramic capacitors are smaller, cheaper, and have large voltage rating over mica and paper capacitor. Applications are these are used as a blocking capacitor, bypassing capacitor, and filter capacitor. Then glass as a dielectric capacitor. Here is a glass used for a dielectric. These capacitors have advantage that they do not need additional coating. Here glass itself acts as a coating, and these capacitors are lightweight, have low losses, having capacitance value up to 10 nanofarad with working voltage up to 500 volt, and applications of these capacitors are used in medium power transmitter. Then capacitors in series. Here we connect the capacitors in series. Here capacitors are placed back to back with the negative electrode of one capacitor connecting to the positive electrode of the other capacitor. Here capacitor C1 having the negative terminal connected to positive of the C2, and negative of the C2 is connected to positive terminal of the capacitor C3, and this negative terminal of capacitor is connected to negative terminal of the battery. If current flows through the circuit, the current can only take one path. Here the formula to calculate the total series capacitance is total capacitance CT is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. So to calculate the total capacitance of the above circuit, here there are three capacitors of 4 microfarad, 3 microfarad and 6 microfarad. The total capacitance CT would be, here the formula is 1 divided by 1 by 4 microfarad plus 1 by 3 microfarad plus 1 by 6 microfarad is equal to 1.33 microfarad. When capacitors are in series, the total capacitance decreases. Then capacitors in parallel. Here positive electrodes of the capacitor are all connected together, and the negative electrodes of the capacitors are connected together. Here positive electrode of the C1, positive electrode of the C2 and positive electrode of the C3 all are connected together to the positive terminal of the battery, and negative electrode of the C1, negative electrode of the C2 and negative electrode of the C3 are common and connected to the negative terminal of the battery, and these called as parallel capacitance. When current is traveling through the parallel circuit, the current can take various paths through the circuits, such as go through any of the branches of the capacitor. That means current from here passes through this C1, then here C2 and here C3. The formula to calculate the total parallel capacitance is CT, total capacitance is equal to C1 plus C2 plus C3 and so on. So for above circuit, the total capacitance CT would be, here C1 having value 4 microfarad, here is there, then C2 having 3 microfarad and C3 having 6 microfarad. So there is total 13 microfarad CT will take. In parallel, we can say capacitors simply add together, hence there is increase in the capacitor. Then charging of the capacitor. Here is the circuit shown having the connection positive electrode of the capacitor is connected to the positive terminal of the battery and negative electrode connected to the negative terminal of battery, and switch is open. Here is a load resistor shown, and here is the shows characteristics of the capacitor. When switch is closed, here when switch is closed at position 1, battery is connected across the capacitor, then the battery is connected across this capacitor like that, and current flows through the capacitor, current flows like that here in this way, and the potential difference across the capacitor begins to rise. Here the charge carriers are collected across the capacitor. As more and more charge builds up on the capacitor plates, the current and the rate of rise of potential difference both are false. Finally, no further current will flow when potential difference across the capacitor equals that of the supply voltage VO. Then the capacitor then fully charged, and the relation between Q and Q0 is given like as Q is equal to Q naught in bracket 1 minus E raised to minus T by RC, and the current in the circuit is given by the equation I is equal to I naught minus E raised to minus T by RC. Then discharging. Here we connect the switch to the capacitor, and the capacitor discharging through the load resistor R, and the here characteristics shows when switch is put in position 2, a large current start to flow and the potential difference across the capacitor drops. As charge flows from one plate to the other through the resistor, the charge is neutralized, and so the current falls, and the rate of decrease of potential difference also falls. Eventually, the charge on the plate is 0, and the current and potential difference are also 0. The capacitor is fully discharged.